Last week we delved into the latest updates of EcmaScript 2023, which was officially released a few weeks ago at the end of June. This didn't come as a surprise, since a new version of EcmaScript has been launched every June for the past 8 years, starting with EcmaScript 2015. However, EcmaScript, which is the language standard that underpins JavaScript, has a history that stretches back further than 2015, because the first version was introduced in 1997. And this means that for 18 years, from 1997 to 2015, we had a different versioning system. It was straightforward. EcmaScript 1 was launched in 1997, followed by EcmaScript 2, EcmaScript 3, and then, unexpectedly, EcmaScript 5. This raises the question, what happened to EcmaScript 4? Isn't there a missing version? And you're absolutely right, there's a noticeable gap between versions 3 and 5, where EcmaScript 4 should have been. But this version never came to be. And the reasons why it didn't, what went wrong, and why it still matters today are the focus of today's video. So hello and welcome to our new Developers Dictionary. Let's start from the beginning, which takes us 30 years back to 1993. To provide some historical context, I myself was 15 years old in 1993. I had a PC with an Intel 486 ASIC CPU, 4 MB of RAM, roughly a 200 MB hard drive, and MS-DOS as the primary operating system. If needed, I could start Windows 3.11 and connect to the internet via a modem with 14.4 kilobit per second, but there was no Google, there was no Amazon, and however, this wasn't a problem. In January 1993, the first ever web browser, Mosaic by Netscape, was released. And if you're wondering how people browsed websites before the advent of web browsers, the simple answer is they didn't, because HTML was only a year old at that point, meaning there were hardly any websites to browse. The few that existed weren't visually appealing, as CSS didn't exist in 1993 either. And all of these technologies were developed in the following years. And one of these was JavaScript. Looking back, I think Netscape was quite progressive and forward-thinking, envisioning the web as an interactive medium rather than a platform for static content. And the first version of JavaScript was released in 1995 as part of Netscape Navigator 2.0, and a year later, in 1996, Netscape submitted JavaScript to the European Computer Manufacturers Association, which is the ECMA, for standardization. And this led to the creation of the language specification today known as EcmaScript, with the first version being published in 1997. This language specification continues to serve as the foundation for JavaScript, outlining the manner and direction in which the language evolves. Initially, this evolution was quite rapid. The first version was released in June 1997, the second followed just a year later in June 1998, and the third arrived a year and a half later in December 1999. And up to this point, everything seemed to be progressing smoothly. However, when work commenced on the next version, EcmaScript 4, things started to go awry. And to understand this, we need a bit of historical context. Netscape Navigator was at version 6, IE was at version 5, and the technology of the year was Ajax, based on the XML HTTP request object. And this technology laid the groundwork for what we now consider commonplace with single-page applications, the ability to run not just web pages but entire web applications in the browser, and so on. Interestingly, the XML HTTP request object didn't originate from Netscape, but from Microsoft. It was one of the major innovations in IE5, introduced to support the web interface of Outlook Web Access for their Exchange email server. So what happened in 1999? What went wrong? Initially, actually nothing. There were three major players involved with JavaScript, respectively EcmaScript, Netscape, Microsoft, and a company we haven't discussed yet, Macromedia. Macromedia was a leading company in web graphics and animation, best known probably for its product Flash. The drama surrounding EcmaScript 4 centers on these three companies and their respective interests and strategies. Let's begin with Netscape. In 1999, Netscape started contemplating the future of EcmaScript, and they appreciated the simplicity and speed of executing JavaScript, its lightweight nature and its pragmatic and flexible approach. But however, Netscape also recognized that JavaScript lacked certain features typically expected from a mainstream programming language. The primary concern here was how to structure large and complex JavaScript applications, as there were no packages, no modules, no namespaces, no components, and so on. And additionally, Netscape felt that JavaScript lacked true object orientation, at least in the sense of Java, instead offering a pseudo-variant with constructor functions, prototypes, and so on. So Netscape's primary goal was to mature the language, making JavaScript more suitable for large and complex projects. And looking back from today's perspective, I think this was a very realistic assessment and a good idea to do so. If there's one thing JavaScript lacked for years and decades, it was precisely that: the language features necessary to structure large and complex applications effectively. While one could argue whether real object orientation was actually necessary, features like packages, modules, namespaces, and so on would definitely have been beneficial to have back even in 1999. The situation at Microsoft was slightly different. Since the introduction of Java in 1995, Microsoft didn't have something to compete. Yes, they had Visual Basic, but it was admittedly already starting to get a bit outdated. They also had C++, so Visual C++, but it wasn't managed code, and it was way more challenging and complex to use compared to Java. Moreover, both technologies lacked Java's internet focus. Therefore, in the late 90s, Microsoft devised a strategy and a new platform called .NET. And even though .NET wasn't officially launched until 2002, work was already well underway by 1999. And .NET aimed to be a platform for everything, not just desktop class like Visual Basic or Visual C++, but also encompassing the web. And for this purpose, ASP.NET was developed, a technology for building server-side web applications with any .NET compatible language such as C# or Visual Basic.NET. And given that Microsoft already had its own implementation of EcmaScript in the web browser, JScript, it made sense to use JScript in the backend as well, which was called JScript.NET, which is essentially server-side JavaScript. Now, Microsoft had two key objectives. Firstly, they wanted JScript.NET on the server to be as compatible as possible with JScript on the client, giving developers the feeling of working with a single and unified language. Secondly, they aimed to enhance the language's capabilities, possibly bringing it closer to what was standard in the Microsoft world at the time. In terms of Visual C++, this meant that a static type system would have been beneficial, at least in an optional way. They also would have appreciated the inclusion of a few keywords like public, protected, private, which are familiar from C++. So even at Microsoft there was an appreciation for JavaScript's strength, but they also recognized its weaknesses. However, their evaluation differed from Netscape's largely due to their different perspectives. It's not a matter of one company being right and the other wrong, they simply had different approaches to assessing certain aspects and the expectations that arose from these. Personally, I wouldn't say that Netscape and Microsoft had drastically different goals. I believe it was more a matter of perspective that influenced many details and shaped their expectations. However, one criticism that can be leveled at Microsoft is that they went ahead and started incorporating some of the planned language features of ES4 into JScript.NET, thereby simply establishing a fait accompli. This approach makes any discussion quite difficult, and it's not very collaborative or at eye level with your partners when one partner just forges ahead. And to add to the complexity, there was also Macromedia. The first version of Flash, released in '96, was primarily about vector-based animations. The second version, released in '97, added significantly more interaction, and Macromedia introduced the so-called actions. Essentially, these were very simple events that could be attached to, but they didn't offer much in terms of programming. And this changed gradually with Flash 3 and then Flash 4, and Macromedia essentially developed its own programming language, though it wasn't particularly practical. Therefore, a new language was created for Flash 5, which was let's call it an interesting blend of EcmaScript 3 and Macromedia's own proprietary constructs. Since the core of this language was still based on actions, Macromedia aptly named it ActionScript. However, they were willing to participate in the future development of EcmaScript and began contributing to the planning of EcmaScript 4 from 2000 onwards. However, the issue was that Flash was highly successful and Macromedia was the sole provider. In plain terms, they had free rein, and they took full advantage of this. Like Microsoft with JavaScript.net, they also started to establish certain facts by integrating the features they found useful in EcmaScript 4 into ActionScript. And the catch was that they didn't have a language fully compatible with EcmaScript 3 to begin with, as ActionScript was, as said, a blend of EcmaScript and their own proprietary language. But when you start implementing features of the next version that have not yet been collectively agreed upon, it doesn't necessarily improve the situation. So in essence, Macromedia exhibited the same uncooperative behavior as Microsoft, creating facts before there was a consensus on specific concepts and approaches. And when you now have two companies behaving this way, it's clear that this approach can't be sustainable and successful in the long run. And that's exactly what happened. This approach worked to some extent for a while, but gradually the collaborative work decreased, and by 2003 it had completely fizzled out. This was partly because in 2003 Macromedia released the new version, ActionScript 2, essentially signaling that reaching a consensus was no longer a priority for them and their own product strategy took precedence. The situation at Microsoft was similar, except they were a year ahead with the already done release of JavaScript.net and the overall .NET framework a year before. Now, was it all worth it? Certainly not for Microsoft. Developer interest in JavaScript.net was so low that the language was already discontinued in 2005 with the introduction of .NET 2. For Macromedia, which was acquired by Adobe in 2005, it took a few more years, but their solo venture didn't pay off either. When Apple introduced the iPhone in 2007 and flatly refused to allow Flash on the iPhone, Flash's fate was sealed. Tragically, Netscape was the real loser of that era. They simply didn't survive Microsoft's aggressive push to market strategy for Internet Explorer, so the only ones who played by the rules ended up suffering the worst consequences. And of course, the entire situation was a disaster for the community, since all the features planned since 1999 were not standardized and JavaScript's further development simply stalled for years. And this changed slightly in 2008, a full 9 years after the initial plans for EcmaScript 4. That year, the decision was made to finally abandon EcmaScript 4 and instead make at least a small step forward. It was decided to finally release a few minor additions and extensions to EcmaScript 3, which were originally planned as EcmaScript 3.1, and to name them EcmaScript 5, at least to give the impression of progress. And this finally happened in 2009, meaning there's a decade between version 3 and 5, which essentially is 3.1. It then took another 3 years until 2012 for all the web browsers to catch up and to finally support EcmaScript 5. So we're looking at a 13-year standstill because two companies, Microsoft and Macromedia, thought it would be a good idea to forge ahead on their own. And for what? For one technology that ended to exist 2 years later, and for another technology that became obsolete a few years after that as well. To prevent the ideas encapsulated in EcmaScript 4 from completely dying out, it was, however, decided to regroup and start from scratch. To emphasize the seriousness of this effort, the new planned version, that is version 6, was given the codename Harmony. But even this effort took another 6 years until EcmaScript 6 was finally released in 2015 under the name EcmaScript 2015. And in this context, it was also decided that future releases should not be as long and arduous, and therefore a new version of the language spec should be published every June. And that's why EcmaScript 2023 was published in June 2023. By the way, if you missed the video mentioned earlier about this topic, you can find the link to it again here in the info card. And finally, the only question that remains is what EcmaScript 4 would have been or what it would have contained. Considering that this could have become a reality as early as 1999 or shortly thereafter, it's quite disheartening to be true. Example given, EcmaScript 4 had a concept for classes. There was a class keyword, the ability to mark fields and methods as public, private, protected. There was static, there was final, and the keyword this would have been eliminated. Just this last point alone could have prevented so many problems and errors over the past 25 years, but it wasn't meant to be. And even though most of these capabilities have been available since EcmaScript 2015, for example, there still is no protected keyword available. But classes aren't everything. There would also have been interfaces, real interfaces in the sense of a static nominal type system, which in turn implies that EcmaScript 4 would have incorporated a static type system. Like in TypeScript, it would have been optional, but type annotations, union types, and all the things that TypeScript has to offer since 2012 could have been available as early as 1999. Granted, it wouldn't have been exactly the same, as TypeScript has a static structural and not a static nominal type system, but fundamentally it's quite astonishing or alarming, depending on your perspective, that these considerations existed about a quarter of a century ago. And speaking of static types, EcmaScript 4 would have also expanded JavaScript's types with new ones such as int, byte, double, and a reliable type for decimal numbers named, surprise surprise, decimal. And this is something we don't have available in either JavaScript or TypeScript today. In EcmaScript 4, you would also have been able to define packages and import them elsewhere. And if you look at today's syntax of import and export, you can clearly see where the inspiration came from. Speaking of inspiration, EcmaScript 4 would also have had support for generics, which reads exactly like the generics in TypeScript today. We would have had tail calls and tail call optimization, function overloading, yield and generator function 16 years earlier, strict mode, and so on. However, in my opinion, the most radical feature would have been an extension planned around 2004 called E4X. E4X stands for EcmaScript for XML and essentially describes the ability to accommodate XML as a standalone data type in JavaScript without having to resort to strings or similar workarounds. And if this reminds you of JSX in React, I can only say exactly that's what it would have been in 2004, natively in your browser, without a precompiler. And when you put all of this together, it's just sad how many years all these ideas were delayed and partially lost and not implemented because two companies thought going it alone was a good idea. Of course, we can't change any of this today anymore, and it's also pointless to engage in finger pointing and say because of this and that happened back then. Nevertheless, I believe it's important to know this history, simply to understand what JavaScript could have been and what it was not meant to be. Because this at least allows us to show respect and gratitude to the people who drove this forward back then and who strived for unity even in retrospect. And perhaps it helps to question technological decisions made today slightly differently, because remembering the history of EcmaScript 4 might make you ask, what interests do certain companies have at certain points when they push a standardization or a specification into one direction or another? And that's something we should all, I believe, think critically about and maybe question a few things more often. Now, how do you see this? Were you aware of this whole story around EcmaScript 4? Did you know what we all missed, what could have been? Or have you not really wondered in the past why there is a gap between EcmaScript 3 and EcmaScript 5? Feel free to write your opinion, your thoughts, ideas, and so on in the comments below. And if you enjoyed today's video, feel free to share it with your colleagues. And last but not least, I wish you a good start, of course, to the new week. As always, take good care of yourself, stay healthy, and then we'll see each other in the next video. In this sense, have a nice day. Bye.